Ladies and gentlemen, welcome back with how to use a multimeter. We're on lesson 2 at this point. If you didn't do lesson 1, of course, go back and do that. We're on lesson 2. This time around, we're learning how to measure voltage. So here's some very big questions that we need to answer in terms of how do we actually measure voltage. We need to know what dial do we actually switch the multimeter to? What is the multimeter actually doing when it's trying to sense voltage or measure voltage? Is the circuit, is it supposed to be powered or not powered? Should it be on or off? Should the circuit stay connected, or should we somehow take parts of it apart? And where do you actually put the leads? Where do you actually put the leads? So if we take a look at our multimeter, I want you guys to tell me, for measuring DC voltage, where do we actually switch it to? So this is the side that we'll switch it to, so we should know that. And then if we look at our circuit here, so here's our snap circuit. It's just a simple series circuit. Here's our 5-volt positive with a 100 ohm resistor connected to a LED, and then there's our negative. So in terms of the voltage that we should expect, we should be expecting to read something right around 5 volts because that's what it says right there, 5 volts. So now my question to you is, if we're selecting voltage on this side here, what number in that range should we be selecting if we're expecting to measure around 5 volts? So if we're expecting to measure 5 volts, 5 is above 2. So we don't want to select 2. We want to go to the nearest one that's above that one, which will then be the 20. So if we switch to 20, all right, now we're in business. Our multimeter is ready. I have my leads plugged in the correct spot, so on. So we are good to go there. Now, in terms of the circuit, should it be powered or should it not be powered? So right now, not powered. And then, of course, to plug it in, it's powered. So in terms of when you're measuring voltage, you're measuring the potential difference. So you actually do need the power of the circuit on. So the circuit should be powered. Because what the multimeter is sensing, so in terms of what is that multimeter actually doing when you're measuring voltage, is it's measuring the potential. It's measuring the difference between 2 points, the electrical potential between 2 points. So we do need to have the power on. Now, in terms of where do we actually put the leads? So that depends on what are you wanting to measure for the voltage. So if I'm trying to measure what is the actual voltage of this whole circuit, then I'm going to go from the start to the end. That's where I'm going to put the leads. So I'd put one of the leads here, I'd put the positive here, and then I'd put the negative here, and watch what our multimeter says. So our multimeter, so 5.33. Okay, that seems about right, because this here is telling me it should be about 5 volts. So yeah, that seems accurate. My circuit's working. So now, what if I'm diagnosing a problem? Let's say I did this, and let's say it told me 1 volt. Well, then I know that there's probably something then wrong with my power supply if it's only putting out 1 volt. So that's in terms of how you diagnose. Now, notice what happens if I put the negative on the positive and the positive on the negative. My question to you is, what's the difference? So you most likely notice that there's a negative symbol on there. So that's saying it's opposite. So that's reversed. We reverse the polarity. So in terms of it's reading, like, it's going through the negative, or it's going through the opposite way. That's why it's showing up as a negative number. So if we go back to positive, do it properly. Now, another thing that I can do is this doesn't necessarily need to be connected. So right now, this circuit is not fully connected. I can still put the positive lead on the positive, the negative lead on the negative. I'm still getting that 5 volts. Another thing that we can do is we can go to different parts of a circuit or like on other sides of individual components, and we can see how much of a voltage drop those components are causing. So if I put the positive here and the negative here, notice that number is lower than 5. What that number is saying, that's a voltage drop. That's a neat thing that we can do is we can take a battery. You can do this at home. You can take a battery and you can measure the voltage of a battery. You can see if the battery is still good or not. So this is a 9-volt battery, so that means we should be expecting it to measure 9 volts. So if I put the leads on there, let's see what it says. That says 2 volts. So this battery definitely is not very good anymore, because this should be saying 9 volts. So this one's basically garbage. And then let's say we take a double A, which should be right around 1.5, depending on what it's made out of. So this battery is saying about 1.6. So this means that this battery is still good. You could even take a multimeter and do that on like a car battery. So that's a very, very good, quick way to tell if a car battery is charged or not, is to put the negative on the negative, the positive on the positive. And if it says it's like 12.6 or something like that, if it's at 12.6, the battery's charged. If it's like 10 or 10.5, 11.0, something like that, well then the battery's not charged. So just in general, that's kind of how we use a multimeter to check for voltage. Alright, so to summarize this, I have some questions for you. In the circuit, when we measure voltage, should the power be on or off? Should the circuit be connected or not connected? And my last question is, where should the leads go when we're measuring for voltage? Thank you very much, ladies and gentlemen, for participating in this lesson.